Welcome to the S-Concrete tutorial video. S-Concrete is a standalone product that details, code checks, and designs various reinforced concrete sections. S-Concrete is also partially integrated with S-Frame and can be fully integrated using the integrated concrete design option. Let's start with a quick explanation of the interface of S-Concrete. As you can see on the left-hand side, we have the various beam, column, and wall sections available to you. At the top of the screen are several shortcut buttons, as well as the code check status boxes, which update every time you make a change to your section. These statuses are also described in greater detail within S-Concrete's design reports, which we'll look at later. S-Concrete also has several info boxes in the visual editor window, including details on material properties defined in the section, section properties, including effective section properties that can be used for analysis, reinforcement summaries at various locations in your section, summaries of material quantities, code check result information, and a high-level description of your specific project. Now let's get a closer look at S-Concrete. As you can see here, we have a T-beam. With the click of a button, you can design L-beams, rectangular beams, rectangular columns, circular columns, I-shaped shear walls that resist lateral loads like wind and earthquake, C-shaped walls, T-shaped walls, and L-shapes. Let's focus our attention on T-beams for now. Typically, we would first edit our section parameters. Choose Section from the Edit menu, or go to the toolbar. Here we would enter or edit our dimensions. There's also a place to specify clear cover, and choose whether or not to check bar spacing and or perform crack control checks. We can also specify our exposure and determine the effective section properties expressed as a fraction of the gross section properties. Effective section properties are then going to be computed for you and can be used to define your structural analysis model in S-Frame. Next, you can choose units, metric or US imperial, as well as the code or standard governing your design. You can see here we support the ACI, CSA, Eurocode, Singapore Standard, UBC, and so on. You can also choose from a list of bar types. We support the American, the British, Canadian, Korean, Singapore, and custom bar types. Next, you would enter the material properties, including the moduli, or you can get S-Concrete to estimate them for you, based on the material properties entered. The next step is to edit the reinforcement. Up to 5 layers of bars can be specified, and for each layer of bar, 2 bar sizes can be assigned. You can use the same bar size for the entire set, or you can mix them up. Let's change one set of bars to 3 number 11 bars. And we'll add a second layer of bars as well, and say 2 number 8 bars in that layer. The same applies to the bottom bars, up to 5 layers of bars, and for each layer, 2 bar sizes can be assigned. You can specify the size and spacing of stirrups, as well as the number of legs you desire. Let's specify 4 legs of stirrups for this situation. They can also be closed or open stirrups, and you have the option of whether or not you'd like to apply the stirrups to your section. You can also specify the size and spacing as face steel and choose whether or not to apply it, whether or not each face of your section has face steel, and whether to include the face steel in the axial load and moment interaction diagram. As you can see, there are 4 stirrup legs, 2 layers of bars, and 2 bar sizes in the first layer, 2 number 8s, and 3 number 11s. And we can see here that's reported in this box here. Now there is an easier way to change the section sizes and the reinforcement by using the visual editor. By dragging the section outline, you can change the dimensions. Factor loads have been entered in the spreadsheet, and as you can see, the section has already been code checked as indicated at the top of the screen. Any changes you will make will automatically be code checked to provide immediate feedback. You can quickly tell how these changes affect your design. You can also use the visual editor to change the reinforcing. Left-clicking the mouse clicks to add bars, right mouse clicks subtract bars. This also applies to the number of stirrups and the size of the bars as well. And the same applies to the face steel and the bottom bars. You can also change the stirrup spacing in the same manner in predetermined increments, which can then be changed along with the number of legs. Next, you can edit or enter factored sectional loads in a spreadsheet. For T-beams and L-beams, uniaxial bending is supported. You can enter axial, torsion, shear, and bending in one direction only. For rectangular beams, rectangular columns, and circular columns, biaxial bending is supported. Bending moments and shear forces can be applied in two directions for true biaxial bending. You can enter an axial load, torsion, shear, and bending in one direction, plus shear and bending in the other direction. It is also possible to copy and paste data from another spreadsheet or import them directly from SRAM. And S-Concrete allows you to enter up to 32,000 load cases. True biaxial bending is reflected in the axial load and moment interaction diagrams. As we can see here, with the resultant moment applied at an angle theta with respect to the horizontal. No interaction formulas are used to generate these diagrams. It is true biaxial bending. And you can view these interaction diagrams for various load cases or corresponding theta value. You'll notice there are three curves displayed: the normal failure envelope with a resistance factor less than 1, the nominal failure envelope with resistance factor equal to 1, and the probable failure envelope, which takes into account strain hardening from the steel. By clicking anywhere on the plot, you can get location of the marker. They are displayed in two locations. And if you're interested in a point anywhere on the envelope, right-click near that point and click the normal envelope in this case. Other parameters will be displayed like the neutral axis depth, the effective depth of the tension force, area of tension steel, and the strain used to evaluate the point of the envelope. These parameters can help you verify that the point in the envelope is correct using hand calculations. For column sections, you could add a hole, either a rectangular or circular shape. You can also get S-Concrete to apply slenderness effects by clicking here to enter the slenderness parameters. Here, slenderness effects deal with the moment magnification between the member's ends. I like to emphasize that this is between the member's ends. It is recommended that moment magnification at the member ends due to lateral loads are handled elsewhere. A product like SRAM can easily determine these second-order bending moments for you. As you can see here, there is a hole in the column. You can drag the outline of the hole with your mouse to make it bigger or smaller. It will also be reflected in the interaction diagram. The greatest effect on the hole will be at the top of the interaction diagram, where the neutral axis depth is relatively large. Composite columns are also supported. We can add a steel shape to embed in our column and adjust the orientation and the offset. We can pick from a variety of steel tables and choose a section from our desired table. You can also use a visual editor to change the dimension. You can also change the dimensions of the steel shape itself, as Concrete will automatically assign the closest section to those dimensions. Let's now remove the steel shape and get S Concrete to find an acceptable solution of its own that meets the code requirements. Click the Automated Design tool. And now let's click the Auto button. And as you can see, the changes are displayed here. As you can see, S Concrete supports multiple layers of bars and columns. You can also view numerical results in a report. You notice the gross section properties are computed and displayed here. The effective section properties are also displayed, and these are the values that you might use in the structural analysis model in S-Frame. Slenderness parameters are displayed along with the input loads and magnified moments, including the resultant moment applied at an angle theta. Shear results are displayed in the segment with intermediate values so that you can verify the results by hand. Numerous code violations are indicated and summarized at the end of the report. A brief description of the code violation is displayed, including a clause reference to this code standard governing your design, showing you exactly where the violation is taking place. It's also possible to add pictures to this report. Let's add this column section to the report now. Let's also add an interaction diagram. As you can see, the column section has now been added to the top of the report. Other diagrams are added at the end of the report. You can also change the location of these pictures in the report and hide various segments that you wish to omit from the report. As we can see here, the N versus M diagram is at the end of the report. And of course, we can do a print preview to see what our final report would look like. As mentioned earlier, S Concrete also supports shear wall sections where the applied loads represent seismic or wind forces. One of the more popular shapes is I shape. The I shape can be rectangular, symmetric, or unsymmetric. You can also define zones of reinforcing at various locations, including the sizes of bars and tie spacing. Additionally, S Concrete allows you to define panel and distributed reinforcing, including bar sizes and spacing, vertical and horizontal bars. Along with those parameters, you can specify 1 or 2 curtains of steel and the hook type at the end of the horizontal bars for seismic purposes. Let's now take a closer look at the C-shaped walls. Let's replace some of the Zone C bars with the Zone B bars. We'll first make the Zone C bars inactive. And make the Zone B bars a 3-direction zone. We'll link the zone dimension with the offset, in this case W5, which is 18 inches in this section. So we'll enter this dimension in the field for W5 and use that dimension to compute the bar spacing. Let's put 4 bars in that region. We'll also enter the number of bars and spacing for the other positions in the zone. Let's zoom into this region and take a closer look. We can drag this line to change the offset. And we can drag the line on the other side of the wall to change the thickness of the panel. Now let's fill the zone with reinforcing bars. Now let's fill the zone with reinforcing bars. And let's also change N3 to 6 to highlight this change. As you can see, the zone is virtually flooded with vertical reinforcing. For C-shapes, S-Concrete supports 2 types of loadings, namely sectional and panel loading. Sectional loads are loads applied to the entire section at the centroid, as you can see from the diagram at the top of this dialog. You can apply axial loads or torsion. For C-shapes, torsional loads are resolved to additional shear forces in the flange. You can also apply a shear and moment in one direction and a shear and moment in the other direction. Panel loading is applied on a panel-by-panel basis, as concrete treats each panel as individual entities in terms of axial load and moment capacity and shear resistance. You also need to assign the type of loading, either seismic, wind, or other. The differences between sectional and panel loading are also reflected in the interaction diagram. As we can see here, this is the interaction diagram for panel 2 by itself. And we can click here to see the results for panel 1 or panel 3 by itself. You can also view sectional load cases by clicking this tab. Again, true biaxial bending is supported where the resulting moment can be applied at any angle theta. S-Concrete can also export numerical results and pictures to Microsoft Word. Let's add this picture to the document. Let's also add an interaction diagram. Click here to export to Microsoft Word. You can change the order of the items in which they appear in the document by clicking the arrow buttons. When you're ready, you can click the Word button to export to Microsoft Word. It's also possible to export this picture to AutoCAD using a DXF file. Click the DXF tool button and specify the layer names to be used in a DXF file. Furthermore, if you have any questions, you can call or email technical support for help. But as a first step, we recommend you click here to access the S-Concrete's online help system. There are various topics available here for viewing. Including engineering topics like moment magnification. If you're looking for additional information, there's a number of discussion topics like the one on sectional and panel loading for wall sections. For those of you who also use S-Frame for analysis, there's a way of integrating S-Concrete's design and detailing capabilities into S-Frame's interface with an Integrated Concrete Design, or ICD license. It allows for an easy way to code check and design and detail reinforced concrete structures all at once. It uses the same interface that you may be familiar with S-Frame and SDO, and provides a two-way link between the analysis software and the concrete design software, as well as the steel design in SDO. You're still able to document your design with the same professional-looking reports that you're used to receiving. And all the while, S-Concrete is still being run behind the scenes, so you're getting the same concrete code checks that you would be getting out of the standalone software. Now, if you don't use S-Frame for your analysis, you can still code check multiple sections at once with the batch processing in S-Concrete. You need to start by defining SCO files, which are S-Concrete's native file format. You can then place those files, representing the different sections in your design, into a common folder and run the S-Concrete batch script, choosing how you'd like to output the information from the design results. Once the design engine has been run, you can export your results into a single text file and view the information there.